Alright, so my name is Aaron,
I'm Walt,
and we're doing the decolorization of crystal violet labs.
and so this is for learning objective 4.2, where we have to determine the order of a reaction based on concentration versus time data, or absorbance versus time data, because of Beer's law.
Okay, and this is going to be the equation for the reaction CV plus OH equals CVOH, and this is going to be the rate for the reaction, and that's going to be K times the concentration of crystal violet to the N power times the concentration of OH to the N power.
And so what we need for this lab is a LabQuest, a SpectraViz, 2.5 times 10 to the negative fifth molar crystal violet solution, 0.1 molar NaOH solution, 2 10 milliliter graduated cylinders, 3 cuvettes, 2 100 milliliters beakers, and then a 50 milliliter waste beaker.
Yeah, start. So the first thing that we're going to do is we're going to turn on the spectrometer so the SpectraViz is attached, and we're going to use the cuvette, make sure we wipe all the cuvettes with the chem wipes, and put them in correctly so that they absorb the light from the wavelengths. And we're going to do a blink so we can get the warm up so that we have the correct wavelengths.
And then after we have done the blank test and calibrated, we would take this out, fill a cuvette with just the crystal violet solution, and measure the peak absorbance value so that we could get the right absorbance testing value. Wipe it, place it, and then record that value. And then after that, we would take 10 milliliters of the crystal violet solution into this beaker and 0.1 molar NaOH solution into this beaker, and mix them together and then pour them into another cuvette. And then from there, we would put that cuvette, wipe it down, and place it in here and measure an absorbance versus time graph for 3 minutes with a 1 second interval.
And you want to make sure that when you mix the NaOH and the Cu together, you're being very quick so that you get the reaction right.
Okay, so today we're going to be determining the rate constant of a first order reaction based on the half-lives of the reactions. And so what we have here is absorbance versus time, natural log versus time, and 1 over A versus time for our crystal violet labs. And so how do you determine which order of reaction it is? Well, you look at the graph and determine which one is most linear. And so because this one is the most linear, the first order, it is first order. And so you can take and find the half-life from this by doing the final natural log of absorbance versus the initial natural log of absorbance, and you get about negative 2.0. And so you go from here and follow it over, and where it intersects the line is where you have a half-life of 15 seconds.
Alright, so now we're going to actually go into the explanation for the half-life equation. So the half-life equation, as you can see, is going to be T1/2 equals 0.693 over K. So we're going to try to isolate K, and we already said that the half-life of this equation is going to be 15 seconds. So then we turn T1/2 into 15 seconds equals 0.693 over K. And then now we're going to isolate K, so we're going to multiply both sides by K. So we're going to have K times 15 seconds equals 0.693, and then we're going to divide by 15. And then we're going to have K equals 0.693 over 15 seconds, and that's going to give us 0.0462 liters over moles per second.